take a look at a confidence interval for the mean when sigma is known using a data set. Okay, so let's take a look at this one regarding GPA. I want to use the data set to find the sample mean, find the sample standard deviation, and construct a 99% confidence interval for the population mean. Assume the population is normally distributed. Again, we need to be told that so that we can go ahead and use the t-distribution. If convenient, use technology. Okay, so the data set consists of grade point averages of 15 randomly selected college students. Okay, so what I have is n is equal to 15. And I went ahead and put the data set already into the calculator by going to Stat and then Edit. Okay, I typed in all of 15 of those GPAs. Okay, so they want the sample mean and sample standard deviation. Okay, we could go ahead and find that by going to Stat, then Calc. This is very basic stuff going back to Chapter 2. If I select one variable, statistics, okay, I'm not finding a weighted mean, so I want to clear out my frequency list. Okay, I put my data in L1. Okay, so I get a sample mean of about 2.353 with a sample standard deviation of about 1.03. Okay, so if I wanted to get the critical value for this, again, I can go ahead and use the table. So let's review that real quick. Okay. Okay, so I'm going to draw a bell-shaped distribution, and this time they want a 99% level of confidence. So I want 0.99 in between positive t sub c and negative t sub c. Okay, the positive one is the one we want for the formula. Okay, so x bar plus or minus t sub c times s over the square root of n. Okay, I'm doing this part just to show you again how to get the critical value. Okay, but I will ultimately end up just getting the confidence interval straight from the calculator. Okay, but I could certainly put these pieces in and find this by hand. Okay, so if I have 0.99 amount of area between these two critical values, I'm going to have 0.005 in one tail. Okay, because if I double that, I would get 0.01, which is complementary to 0.99. So remember, the whole area under the curve has to be 1 or 100%. Okay, so if I partition this curve to have 0.99 in between two symmetric values, then I have 0.005 amount of area in each one. Okay, so my sample size is 15. My degrees of freedom will be 14. Reading down to 14 degrees of freedom, and find my column that corresponds to 0.99. You see this last column here, that's my level of confidence. I have 0.005 amount of area in one tail, and together I have 0.01 in those two tails. Okay, so the critical value is 2.977. Okay. Now let me show you how to get that on your calculator. If you have an older TI, then you won't have this capability, but for those of you that have a newer TI, there is an inverse T distribution, okay, built into the calculator. So finding T sub C using the TI 84. Okay, you have to be careful with this though, because it's expecting a cumulative area. Okay, so this needs a cumulative area. All right, let me underscore that, because when we used the table, we weren't finding a cumulative area. Okay, we were partitioning the area symmetrically, which is the correct thing to do. However, when we're using the TI-84, it's expecting a cumulative area from negative infinity up to your value in question. Okay, so we have this upper critical value, T sub C, and we have 0.005 area in that upper tail. Okay? I'm just re-sketching this part up here. So cumulatively, from negative infinity up to my point in question, I have 0.995. This does not mean I'm finding a 99.5% confidence interval. It just means that this is the cumulative area from negative infinity up to this positive critical value. And that's the area I need to input into the calculator. Okay, so if you inputted 0.99, it's not going to give you the right critical value. Okay, so to get that, I want to go to my distribution option on my calculator. And on mine, it's option 4, inverse t. It's expecting a cumulative area and the degrees of freedom. Okay, so we get 0.9768. Now, if we look back at using the table, rounding to the nearest thousands, that's about the same value I got. Okay, so if I rounded the nearest thousands, this is what I get from the table. So if you want to use your calculator, if you have a newer TI and you just want to find the critical value that way, that's fine. If you have an older calculator, you don't need to worry about it. All the level of confidences that they give you, you should be able to get using the table. Okay, then let me know if you don't. I'll send a note into the publisher. Okay, so those are all the pieces you need to plug and chug by hand. But the instructions said, if convenient, use technology. So I'm going to go ahead and do that. Okay, so I'm going to get the confidence interval directly from the calculator by pressing Stat, right arrow over to Tests, and I want to scroll down to the t interval. Okay, and I have two options. I have the summary statistics, or I have the raw data. Now in this case, I put the raw data in a list to begin with, so I'm going to go ahead and use that. Okay, so if I left arrow over and select data, my screen changes a little bit, and then I have to tell it where my information is. Okay, so I'm going to change that to L1 and change my level of confidence to 0.99 and then enter. Okay, so my confidence interval using the calculator goes from about, so this is a 99% confidence interval, goes from about 1.5599 up to 3.1467. Okay, now look at the output. Remember in the problem it had asked for the mean and standard deviation, and we went to one variable statistics? Well, we could have jumped directly to the t interval, and in the output it gives you that. Okay, so it gives the interval, it gives the summary statistics that you need, and it gives the sample size. The thing it doesn't give you is the critical value, which you can get from the table or you can get from the calculator using the inverse t. Okay, so let me just double check that I put in the correct confidence or level. Yeah, I did. Okay, just want to double check that. Okay, so again, please feel free to use your calculator. I certainly don't want you to be finding the standard deviation by hand at this point.